In this lesson, I'm solving the specimen paper 1 that is released by IBDP recently. So I hope this is helpful for you for a class of 2021. So the first question is to solve actually 2 ln x equals to ln 9 plus 4, giving your answer in x equals to p e to the power q form. So what we do is, in this question, we basically have to get rid of x. We get rid of the ln term. So that's here ln 9. And what we can do is, we can write down 4 as 4 times ln. Until I introduce this, the ln term, it becomes a little difficult to write them a single log term. So ln, this is going to be 9 times e to the power 4, because this comes back in the power, and that's 2 ln x. So ln x that we get, ln x squared is ln 9 e to the power 4, and you get x squared as 9 e to the power 4. And if you solve for x, you get here you get 3e squared. So that's x is 3e squared. So that's what they wanted. So p is 3 and q is 2. Now number 2 is to solve for k, given that this is a probability distribution of a discrete random variable x. Now, since we know that this is a probability distribution, so the net probabilities should add up to 1. So this all should add up to 1. So if I add up, I get k squared plus 7k plus 2 minus 2k plus 3k squared. So you get 4k squared plus 5k and plus 2 equals to 0. So equals to, not equals to 0, this will be equals to 1, because the net probability add up to 1. Now when you solve this, you get 4k squared plus 5k plus 1 equals to 0. And now if you factor this out, it's 4k squared plus 4k plus k plus 1 equals to 0. Now if you take 4k, k plus 1 plus 1k plus 1, you solve for this. So you get k is negative 1 and k is negative 1/4. Now if I take k as negative 1, here you can clearly see that my probability of 1 itself become 1 squared. So that's why this is ruled out, and you take negative 1/4. And if you plug negative 1/4, you can check the values are meaningful. So the k value here is negative 1/4. Here the third question is u1 5 times u1 minus 8, 3u1 plus 8. Show that u1 is 4, and these are the first 3 terms of arithmetic sequence. So if the sequence size and arithmetic difference is the same, so like 5u1 minus 8 minus u1, that's my first difference, like this minus this, equals to this minus this, which is 3u1 plus 8 minus 5u1 minus 8. So when you solve this question, this 4u1 minus 8 equals to 3u1 minus 5u1 is negative 2u1 plus 8 plus 8, because this minus makes it positive. So basically it is 6u1 equals to 24, and u1 is nothing but 4. That's what we wanted to prove. And now the B part is prove that the sum of the n terms of arithmetic sequence is squared number. So the SN formula for arithmetic sequence is n over 2, 2u1 plus n minus 1 times difference. Now, since we got u1 is 4, and this is 5 times 4 minus 8, which is 12. So the difference that you see is 8. So that's, now here this is sum of first n terms, don't plug any n value. So n over 2, 2 times 4 plus n minus 1, that's nothing but, here it is, and as it is, and difference is 8. Now when you open this bracket, it is n over 2, 8 plus 8n minus 8. This and this get cancelled, and you get 2 4n squared, which is also nothing but 2n the whole squared, which is a square number. So that's what we wanted to show, that this is a squared number. For question number 4, what we have got is, we have got f of g of x. F of g of 2 is negative 3. So first we find out f of g of x. Here's the f of g of x is going to be ax plus b minus 2. And if I plug x as 2 here, so I get 2a plus b minus 2 equals to negative 3. So that gives me 2a plus b equals to -1. That's my first equation. And the second equation is when you take g of f of 1. So first you find out g of f of x, which means that you replace this x with f of x. So it'll be a times x minus 2 plus b, and you replace x with 1 then. So that's going to be a times 1 minus 2 plus b, that's negative a plus b, and this value is equals to 5. So when you solve these two equations, we get 2a plus b equals to -1 and negative a plus b equals to 5. So if I subtract these two equations, you get 3a equals to -6. That gives me a is -2. And once you solve for a, once you get the a value is -2, so you get -4 plus b equals to -1. And that gives you b as +3. So that's how you do the question number 4. So for question number 5, they have given that there is a function and find the value of b for which the graph has exactly 1 point where the gradient is 0. So obviously, since it is linked with the gradient, you take the derivative. Now the derivative of this function, first you apply quotient rule. So x plus 2 the whole square. So this f dash x is x plus 2 the whole squared, x plus 2 as it is, times 6x plus b minus, then you differentiate the other one, which is 3x squared plus bx as it is, times x plus 2 derivative is 1. Now you open up the brackets. So obviously this is the derivative that you have got, and this should be equals to 0. And now after solving this, let's see what we get. So 6x squared plus bx plus 12x plus 2b negative 3x squared negative bx equals to 0. So when you see that, this cancels, and anyway this cross multiplies to 0. And what we get is 6x squared minus 3x squared is 3x squared plus 12x plus 2b. And this should be equals to 0. Now, since it's a quadratic, now this must have only one root. So when you do b squared minus 4ac for this, it must be equals to 0. Since they would just have got one exact point, it'll be 12 squared minus 4 times 3 times 2b equals to 0. That's 144 equals to, so it's 4 3s are 12, 2s are 24, 24b, and b is 144 over 24. That's nothing but 6. So that's the value of b if you take, and for that, in that case, the equation to the curve will have only 1 point where the gradient will be 0. So let's go on to the 6th one now. The question number 6 actually is about the L'Hopital rule. So L'Hopital rule is basically if your function is of the form 0 by 0 or infinity by infinity, the limit can be differentiated. Like if the equation is of the form f of x over g of x, you can find the limit by doing f dash x over g dash x. So when I plug x as 0, you can see it's coming 0 over 0 format because tan 0, 0, 0 times anything is 0. So limit x tending to 0, 2x cos x squared over 5 tan x is gonna be the product rule in the numerator. So that's your 2 times cos x squared plus 2x times cos. The derivative of 2x cos x squared is basically the product rule in the numerator. So 2 times cos x squared plus 2x times, that's this part, times derivative cos x squared, which is negative sine x squared, times 2x, which is the derivative to x squared, over derivative phi is phi sec squared x, and this is obviously write down the limit x tending to 0. Now if you substitute the values here, so what we get is 2 times cos 0, which is 2, plus this is 0. If you plug into here, you get 0 over 5 sec squared 0. So that's 0, 5. So it is the limit for this is 2 over 5. So for this question number 7, what we have is we have a quadrilateral PQRS, and PQ has been given as x SR has been given as y. These are the angles, and you have to write down PS in terms of x, y, sine beta, and sine alpha plus beta. So what I do is, in this problem, I first construct a side here. So let's say I take t, this side is t. So this length is going to be y minus x. This length is going to be, this is your x, this entire length. This length is x, and this length is going to be, here is going to be y minus x. Since this angle is beta, this angle is also beta, and this angle is going to be pi minus alpha plus beta. Now, if you apply sine rule in this triangle, we get the answer. So sine beta over ps equals to sine pi minus alpha plus beta over y minus x. So when you make p as the subject. So before I do this, just remember the sine pi minus theta is sine theta. So this is going to be same as sine alpha plus beta over y minus x. So then you just make p as the subject. So when you make p as the subject, it is nothing but y minus x times sine beta over sine alpha plus beta. So that's how you do question number 7. For question number 8, this question is about the vectors. Basically, how we have got L1 and L2. These are the two lines that they have given. Show that the L1 and L2, they are never perpendicular. So when you're finding out the equations, the angle between two lines, if they're perpendicular, the dot product of the direction. So let's say if D1 and D2 are the directions of both the lines, the dot product should be 0. Now here they are saying that it is never perpendicular. It means that we should never get an answer when I take dot product equals to 0. So let's take the dot product of the directions. So 2, 1, and m, and 2, negative 5, and negative m. This should be basically should not be 0. So just write down 4 minus 5 plus m minus m squared. Let's see if it is not equals to 0. So that's negative 1, negative m squared is never going to be 0. That's obvious, because this is always going to be a negative number, and which is never going to be 0. Hence that proves that these lines are never perpendicular. Next one is that consider another plane where they have given x plus 4y minus z equals to p, where p belongs to real numbers. Given that L1 and p does not have any point in common, find the value of m. Now, since the L1, so assume that this is the plane that I have, and if the line is parallel, it does not have anything common, means it shouldn't intersect this. It means that the line and the plane is parallel. And if the line and the plane is parallel, it means that the normal to the plane and the direction of line, they are going to be perpendicular to each other. So this is the normal. This is the direction of the line. The normal to this plane, as you know, that if your plane is ax plus by plus cz equals to d, the normal is given by a, b, and c. And the direction of line L1 is 2, 1, and m. So the 2, 1, and m dot product with 1, 4, and negative 1, this should be 0. So that gives me 2 plus 4 minus m equals to 0. So that gives me m equals to 6. So for m equals to 6, they are never going to have a common point. And the condition on the value of p for which it does not have anything in common. So if it does not have anything in common, so this line contains a point 3, negative 2, and 0. So if I say 3, negative 2, and 0, there's no point in common. It means that 3, negative 2, and 0 should not lie on this plane. So it means that it must not fulfill this equation. So with 3 plus 4 times negative 2 and minus z equals to, 0, it should not be equals to p. So p should not be equals to, basically from here, if you look at 3 minus 5, 3 minus 8, that's negative 5. So p should not be equals to negative 5. So p can be anything, but p should not be negative 5. As far as the question 9 is concerned, 2n minus 1 theta. And this should be equals to sine 2n theta over 2 sine theta. So what I do is I take n as basically here 1. So I take the left hand side is cos theta, and let's check what's right hand side. So right hand side will be sine 2 theta over sine 2 sine theta, which you apply the double angle, which is sine theta is 2 sine theta is sine 2 sine theta can be written as, sine 2 theta can be written as 2 sine theta cos theta over 2 sine theta. So this cancels out and you get cos theta. as the answer. Now the next step is to find out, let's say, the, uh, assume n equals to k is true. So that gives us cos theta plus cos 3 theta and so on, plus cos 2k minus 1 theta plus, this should be equals to sine 2k theta over 2 sine theta. So after this, what happens is if I take n equals to k plus 1, what I should get is cos theta plus cos 2k minus 1 theta. And this is up till kth term. So my k plus 1 term, and you replace this k with k plus 1. So it'll be cos 2 times k plus 1 minus 1. If you simplify this, you notice that that's nothing but 2k plus 1 theta. So this should be equals to sine 2k plus 2 theta over 2 sine theta. Because if you replace n with k plus 1 here, you get sine 2k theta. This is what I have to prove. So up till here, if you see, the sum already is sine 2k theta, the sine 2k theta over 2 sine theta, plus cos 2k plus 1 theta. If you take LCM of this, what I get is basically sine 2k theta plus 2 sine theta cos 2k plus 1 theta over 2 sine theta. And if you look at here, this is 2 cos A sine B. So 2 cos A sine B. So let's say angle A, if I take as cos 2k plus 1 theta, and B, if I take it as, let's say, theta. So this same thing can be written as sine of A plus B. So sine of 2k plus 1 theta plus theta, and minus sine of A minus B, so 2k plus 1 theta minus theta over, obviously we have this part I've written, and obviously before that we have sine 2k theta. Now if you simplify this, it'll be sine 2k theta itself, because plus theta minus theta get cancelled. So you got sine 2k theta, which get cancelled with this. And of course we got in denominator as well, which is 2 sine theta. And if you simplify this, you get sine 2k plus 2 theta over 2 sine theta. Now obviously you got to write the general statement. This is what I wanted to prove. You can see that. And just write on the general statement after this. So this is section B now. So for the 10th question, they have given that there's a spring attached, there's a ball attached at the end, and the height can be modeled by 0.4 cos pi t plus 1.8. And what you have to do is you have to find out the values of when it was initially released. So when it was initially released, it means find out h of 0, that is 0.4 cos pi times 0 plus 1.8. Cos 0 is nothing but 1, so that's 0.4 plus 1.8, that's 2.2. So that's how you find out the value. Now the B part is find the minimum height of the ball above the ground. So when you find the minimum height, now you have multiple ways to do this. Like this word is like calculus key term. So what you could do is you can do that way. But since I know that the cos oscillates between 1 and -1 for any value, I can just take the minimum value. This is -1. So what happened is my minimum value for this height will be 0.4 times -1 plus 1.8. That comes to be 1.4. You could have done also using calculus, like you could just do the derivative of this, like you could do h dash t, which is negative 0.4 sine pi t times pi. And if I equate this to 0, so what we get is sine pi t equals to basically 0. And you can see that if I take t as 0, 1, 2, and so on, you get the height. Now you can see that if I take t as 1 here, we get if I take t as 1, so you get the value as 0.4 cos pi times 1 plus 1.8. That's going to be, I put t as 1 here, so that's going to be negative 0.4, because cos pi is negative. 1, so that's 1.8. That comes to be 1.4. The answer is 1.4. Now for the C part, you have to basically show that the particle takes 2 seconds to return to its initial height. The initial height was 2.2, so I could just equate zero point 0.4 cos pi t plus 1.8 equals to 2.2. Initial height was from first part, that's where you got. And now since it's the same height, we equate them. So this, if you bring it here, so you get cos pi t equals to 1. Now, so you get pi t equals to either 0 or 2 pi and 4 pi and so on. So that you notice is t is 0, 2, 4 and so on. So you can see that it returns to after every 2 seconds. And the same could have been done by just finding the period of this. Because it started from here, it went down and it coming back to 1. So it completed one oscillation and that's nothing 2 pi or pi. So that gives also the 2 seconds. So after 2 seconds, it returns out there. The D part is for the first 2 seconds of its motion, find out the amount of time for which the ball is below this height. So what I do is I first find out where is this equals to this height. So I would take zero point 0.4 cos pi t plus 1.8 and equate to 1.8, 0.2 plus zero point 0.2 root 2, 1.8 and 1.8 cancel. So you get cos pi t equals to 0.2 root 2 over 0.4. That's nothing but this is going to be, this cancels out. So that's your 2, which is 1 over root 2. So cos pi t is 1 over root 2. So that gives you the first answer, which is pi t, that is nothing but pi by 4. That's your first answer. And the second answer, if you see, this is pi by 4 here. Since cos is positive, this value is positive, so the other value is here, this pi by 4. And this answer, the second angle will be, which is this one, which is 2 pi minus pi by 4, which is 7 pi by 4. So it's like at pi by 4, the ball came down at pi by 4. That's the point here. It's, you have to solve for t, so that t gives t is 1/4 and t is 7/4. Because pi t is that. So at 1/4, the height is exactly this much. And in between, it is below that. And after that, it goes up. So at 7 by 4, it returns back. So time where it is below this height is basically 7 over 4 minus 1 over 4. That comes to be, basically, this is 6 over 4. That's 1.5 seconds. So for party, we have to find out the rate of change of ball's height when t is 1 over 3. So what you do is just simply, as you know, the rate of change of height is nothing but the derivative. So h dash t is going to be 0.4 negative sine pi t times pi. And the derivative of 1.8 is 0 anyway. So it's going to be negative 0.4 pi sine pi by 3. If I take t as pi by 3 here, so that's going to be negative 0.4 pi times root 3 over 2. That's negative 0.2 pi root 3. So that's how you find out the value of the rate of change of height. For question number 11, what we have is f of x is 3 over x squared plus 2. You got to sketch the graph of this function clearly, stating the asymptote. Now what we have is, first, before you sketch this, I would ask you to sketch, let's say, x squared plus 2 graph, which is something like here. And then sketch the reciprocal of that. That makes a lot of sense. 0, 2, and then you sketch the reciprocal. So you, at this point, actually the graph is going to, the reciprocal graph will be something like here. And this will be cutting at 0, half. Doesn't seem like, but it's 0, half. So that's the graph of this part, and then there's a vertical stretch by 3. So you can see that the graph will slightly get stretched along y equals to, by 3 you can see. So it'll be this point that you notice. Now it'll be at approximately, this is going to be 0, 3 over 2. So now what we have is basically, this is the graph of this part, and you got to mention the asymptotes. The asymptote is x-axis. So the asymptote that we have is here is y equals to 0. And so as a result of this, now what we get is a particular bell curve. So the next part is to find out the region R, which is between x equals to 0 and x equals to root 3, is the find out the area bounded between that part. So this like 0, if you could see that, that was the earlier graph. So this is 0 and root 6 here. So what we get is this is the point, this is the area that I have to find out. So you integrate this 2 over x squared plus 2 from, let's say, 0 to root 6. And what we get is, take 2 common, and so we get 1 over x squared plus 2 dx. And now this is nothing but the format. If you have integration of 1 over a squared plus x squared, it is 1 over a arctan x. So arctan x over a. So what we do here is, this integral is going to be, this is root 6. So that's going to be 2. So you can take this, first you can take this actually 3 outside. So this is 3 here, not 2. So 3 outside, and in this integral is going to be 1 over root 2 and arctan x over root 2, and then you put the limits 0 to root 3, 0 to root 6. So what we get is, now if I do that, so 3 over root 2 is the first part here, arctan. So that's your tan inverse of root 6 over root 2 minus tan inverse of 0. That's going to be 0 itself. And this part is going to be 3 over root 2 times tan inverse of root 3, which is pi by 3. That's going to be pi over root 2. And if you take the rationalization, multiply by root 2 and divide by root 2, that becomes pi root 2 over 2. That's what you wanted to prove for the part B. So for part C, they're saying that x equals to k line divides the above region that you got. So the above region is from, this is root 6. And there is some k value that gives both the areas equal. Now, if both the areas are equal, so this area is going to be root 2 pi over 4. Because if I divide this answer by 2, so root 2 pi over 4, that's going to be this area. Now, this area is basically going to be, if I integrate the same function that we integrated earlier, that's 3 over x squared plus 2 from 0 to k. This should be equals to root 2 pi over 4. And now we already have this integral of this. That's 3 over root 2. This was tan inverse of x over root 2. And you put the limit 0 to k, and we get root 2 pi over 4. So what we get is 3 over root 2 tan inverse of k over root 2 minus tan inverse of 0. Anyway, if you do, that's going to give you the answer as 0 equals to root 2 pi over 4. So now what you do is, after this, basically, is you find out the tan inverse value. So tan inverse k over root 2 equals to, you cross multiply it here. So that's going to be 2 pi over 12, which is pi over 6. 2 pi over 12, which is pi over 6. So bring it this side. So tan inverse of k over root 2 is pi over 6. That gives me k over root 2 is equals to tan pi over 6. That gives me nothing but 1 over root 3. So what we get is k equals to the root 2 over root 3. That's going to be k values root 2 by 3. So that's what is the answer. Now the next part is that let m be the gradient to the curve when y equals to f of x. So gradient to the curve when you talk is basically nothing but the derivative. So f of x is 3. So I'll just take this here. So f of x is 3 over x squared plus 2. That gives me 3x squared plus 2 to the power negative 1. That'll be 3x squared plus 2 to the power negative 2, and obviously negative 1 here times 2x. So it'll be negative 6x or x squared plus 2 the whole square. And yeah, so that's what you wanted to prove. Then E part is show that the maximum value of m is this. Now when you say maximum value, it means you got to differentiate this one more time. So basically, the maximum value this you'll obtain by differentiating one more time. So it'll be x squared plus 2 to the power 4. And then you do the derivative of this x squared plus 2 the whole squared minus, into minus 6 and minus of minus 6x times x squared, this derivative, which is 2 times x squared plus 2 to the power 1 times 2x. Now, when you simplify this, when you expand the numerator, so when you equate this to 0 now, so when you simplify this, you could take x squared plus 2 common, and you notice that this is what you get. So if you equate this to 0, what we get is x is plus or minus 2 over root of 2 over 3. And obviously, to get the maximum slope, you plug this x value out here. And so you'll notice that if I plug this value here, because the maximum slope, maximum value of m, is, so that's why I'm equating this slope of slope, like the derivative of the derivative, because m is like a quantity and you want to find out the maximum value of this m. So that's why you do the derivative of this, equate to 0, you get the x value, and to get the maximum value, you plug in x as this. So I get negative 6 times, since x you're taking positive, that you take x as root 2 over 3, here. So what we get is, this value of m, if you take positive value, getting the negative value. So here you take x as negative root 2 over 3 and divided by root 2 over 3 the whole squared plus 2 the whole squared. And if you simplify that, you'll notice that that's going to be 27, 32 over the root 2 over 3. So there's 2 points. Out of this, you could have checked which one is maxima or which one is minima. So at maxima is actually occurring at the negative root 2 over 3. That's why I put this value. That's how I do this question. So this is the last question on this paper. So we have to use the binomial expansion, cos theta plus I sine theta to the power 4, and write down the answer in terms of sine and cos. So as you know, the Pascal's triangle for fourth row, it is 1, 4, 6, 4, 1. And what you could do is you could just simply use that. So that'll be cos raised to 4 theta plus 4 times cos cube theta I sine theta, and plus 6 cos squared theta I sine theta the whole squared, and so on. And the last term will be I sine theta to the power 4. And when you simplify this, what you get is, basically, if you open up the bracket, make sure that like I squared, you write down minus 1, I cube is nothing but I squared times I, which is negative I. So if you simplify that, what you notice is the real part you get is this, and imaginary part you get this. So that's the first part we wanted. And the next part, what we have is use de Moivre's theorem to show that the cot 4 theta is this. So now what we do is, now since we got this is nothing but cos 4 theta plus I sine 4 theta. So what we do is we're just going to take the real part, and cot 4 theta is cos 4 theta over sine 4 theta. So what I'm going to do is I'm just going to take this part, which is cos to the power 4 theta minus 6 cos squared theta sine squared theta, sine to the power 4 theta plus sine to the power 4 theta. I'm going to just divide it by 4 cos cube theta and sine theta minus 4 cos whatever this particular term is. So this is the exact value of cot 4 theta. This is the cot 4 theta. And now what I'm going to do next is basically, I'm just going to divide numerator and denominator by sine to the power 4 theta. So if I divide numerator by sine to the power 4 theta, this is going to be cot to the power 4 theta minus. Now 6 cos squared theta sine squared theta, if I divide by sine raised to 4 theta. So sine square cancels and you get minus 6 cot squared theta plus 1, because that's going to be 1, divided by denominator also dividing by sine to the power 4. So it'll be 4 cot cube theta minus 4 cot theta, because if you divide by sine to the power 4, sine to the power 4, every term basically dividing by sine to the power 4, this is what you get, and this is nothing but cot 4 theta. Now C part is, we have to use the above identity to prove that x squared minus 6x plus 1 equals to 0 has roots cot squared pi by 8 and cot squared 3 pi by 8. Now if you notice, this equation that you have is, it's actually here. If you see, if I take, let's say, cot 4 theta as 0, so what we get is 0 equals to cot to the power 4 theta minus 6 cot square theta plus 1 equals to 0. And so what happened is that this is actually, if you look at the cot theta, is nothing but x. If I look at, so it is like cot square theta is nothing but x. So it's like x squared minus 6x plus 1. So what happened is that if I solve this equation, like cot 4 theta equals to 0, if I solve, so what are the answer you get? So the cot square theta will be the root of that equation as well. So what we do is we find out the cot 4 theta is 0. So wherever, let's say cot 4 theta is 0. So cot 4 theta is 0 means basically at the points where cos is 0. So it'll be like pi by 2, 3 pi by 2. So that's where it is 0. So you get theta as pi by 8 or theta as 3 pi by 8, which means that cot square, as you can see that cot square theta is the root of this. So it'll be cot square pi by 8 and cot square 3 pi by 8 is basically the root of this equation. So next part what you have to find out is the value of cot square 3 pi by 8. So if you are finding out the value of cot square 3 pi by 8, because you know that the one of the root of this is cot square 3 pi by 8. So we solve using quadratic formula, negative b, which is 6, plus minus root of b squared, which is 36, minus 4 times 1 times 1 over 2. So it'll be x equals to 6 plus minus root of 32 over 2. And if I simplify this, it is 3 plus or minus, if I take 4 out from here, that's going to be 2. So that'll be 3 plus or minus root 2. Now, since cot square 3 pi by 2, now cot square pi by 2 is bigger than cot square 3 pi by 8. Cot square pi by 8 is bigger than cot square 3 pi by 8. So take cot square 3 pi by 8, you take the value as 3 minus root 2. So that's how you get the D part. Now, last part is to deduce a quadratic equation, the integer coefficients having the root of cosec square pi by 8 and cosec square 3 pi by 8. Now, since here what we got is the relation between the two roots, that cot square pi by 8, 1 plus cot square pi by 8 is nothing but cosec squared pi by 8, cosec squared pi by 8. And so what we take is, if I take cot square pi by 8 as, let's say, x, so now what we can do is basically cosec squared. So 1 plus cot square theta is cosec square theta. So cot square theta, if I take cosec square theta here, so now since I know that the cot square 3 pi by 8 and cot square 3 pi by 8 is, I mean, pi by 8 is the roots of this equation. And I know the relation is 1 plus cot square pi by 8 is nothing but cosec square pi by 8. So if I take, let's say, cot square pi by 8 as equals to cosec squared pi by 8 minus 1. So let's say if I take this value as y minus 1. So what happened is that if you replace, this is, and you know that this is x value, because this is one of the root of this equation. So if I take this value, x is nothing but y minus 1. So it'll be y minus 1 the whole squared minus 6 times y minus 1 plus 1 also will be equals to 0. So if you solve for this, y squared minus 2y plus 1 minus 6y plus 6 plus 1. So equals to 0. So y squared minus 8y and plus 8 equals to 0. So that's going to be the equation with the real coefficients. I hope this is helpful. It takes a lot of time to create such lessons. So definitely share with your friends.